Welcome to the clinic. Today, we're diving into an explainer that diagnoses, treats, and, fingers crossed, completely cures one of the absolute biggest traps in Cambridge math exams, unit conversions. You know that feeling, right? You walk out of the exam hall feeling totally confident, only to get your paper back completely covered in red ink, just because a decimal point mysteriously shifted. Well, if that's you, you're in the right place. Let's get your mathematical health back on track. And hey, before we jump in, make sure to subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations.
So, let's start with a quick sanity check to test your intuition. This is a classic measurement trap that catches, honestly, so many students off guard. Okay, you already know that 1 meter equals 100 centimeters. Pretty basic stuff, right? So logically, how many square centimeters are in a square meter? Is it 100? 1,000? Before you lock in that answer, let me tell you, this exact thought process is exactly where the exam leakage begins. Hold on to your guess, because we're going to uncover the real answer in just a minute.
Here's our patient chart for today's session. We've got a solid plan, starting with the 1D Basics Clinic, moving into capacity and liquid measures, then tackling that tricky area conversion trap, mastering volume and 3D mastery, and finally, doing some clinical trials with practical exam applications.
All right, Section 1. The 1D Basics Clinic. Let's establish our baseline. It's kind of fascinating just how fundamental these connections are. What we're looking at are the standard metric connections for length and mass. And trust me, you absolutely have to have these memorized before even thinking about moving into complex dimensions. For length, we've got 1 kilometer equating to exactly 1,000 meters. 1 meter, that's 1,000 millimeters or 100 centimeters. And 1 centimeter is 10 millimeters. On the mass side, everyday units like kilograms and grams follow a similar rule, with exactly 1,000 grams in a single kilogram. Take a mental picture of this right now. These 1D linear baselines are the raw ingredients for literally everything that follows.
Moving on to Section 2, Capacity and Liquid Measures. Let's look at the containment rules.
You know, you'll often hear the words volume and capacity tossed around interchangeably in daily life. But in a math exam, precision is everything. Capacity is the specific term we use when a volume is actually filled with a liquid or a gas. Think of it this way. When you're measuring the physical space a solid block takes up, well, that's volume. But when you're pouring lemonade into a bottle, now you're dealing with capacity. And the foundational ground floor rule here is that 1 liter equals exactly 1,000 milliliters. Now, here is the absolute crucial point. How do these two worlds, liquid capacity and physical 3D volume, actually connect? This right here is the critical crossover point you have to remember for your exams. 1 milliliter is exactly the same as 1 cubic centimeter. Picture a tiny little cube, right? Just 1 centimeter wide, 1 centimeter deep, and 1 centimeter tall. That little cube holds exactly 1 milliliter of liquid. This simple one-to-one conversion is your golden key for unlocking those complex exam questions that mix liquids with solid dimensions.
Okay, Section 3, the area conversion trap. Let's talk about the misdiagnosis.
And this brings us right back to our opening question. In straight-up linear math, 1 meter is 100 centimeters. But an area of 1 square meter isn't just a line. It's a flat square that's 1 meter long and 1 meter wide. So to find the area in centimeters, you don't just use 100. You have to multiply the length in centimeters by the width in centimeters. That's 100 centimeters times 100 centimeters. Look at that exponential difference. Because you multiply 100 by 100, 1 square meter actually equals 10,000 square centimeters. If you guessed 100 earlier, hey, don't worry, you are definitely not alone. But now you see exactly why area conversions require us to square the conversion factor.
Next up, Section 4. Volume and 3D mastery. Time for the ultimate cure.
Now, stepping into 3D space, the conversion becomes exponentially different yet again. Think about a cubic meter. It's a giant block, 1 meter long, 1 meter wide, and 1 meter high. If we convert all those sides to centimeters first, we're multiplying 100 centimeters by 100 centimeters by 100 centimeters. You literally have to cube the conversion factor. The result, 1 single cubic meter equals a staggering 1 million cubic centimeters. Let that sink in for a second. Moving from 1D to 3D takes us from 100 all the way to 1 million. Memorize this process, and I promise you will never fall for the volume trap again.
All right, Section 5, Practical Exam Applications. Let's run some clinical trials.
Let's take a look at example 39.1 from our source material. So Misha is baking some cakes. One recipe needs 1.6 kilograms of flour, and another needs a half kilogram. The question simply asks how much he needs altogether. The symptom here? Mixed units. We've got decimals and fractions of a kilogram mixing together. The best strategy is to convert everything to a single, whole number unit before you do any math. In this case, let's just convert it all to grams. 1.6 kilograms becomes 1,600 grams. A half kilogram, that becomes 500 grams. Now it's a breeze. Simply add them up. 1,600 plus 500 is 2,100 grams. You can totally leave it right there or confidently convert it back to 2.1 kilograms. Nice, clean, error-free arithmetic.
Let's follow up with part B of that exact same example. Now, Misha has a brand new 3-kilogram bag of flour. How much is left after he makes the cakes? Once again, apply the cure. Don't try to subtract 2.1 kilograms from 3 in your head, especially if you know you're prone to decimal errors under exam pressure. Instead, simply convert the entire new bag to 3,000 grams. Then, take the total we found earlier, 2,100 grams, and subtract it. 3,000 minus 2,100 leaves a perfectly neat 900 grams, or 0.9 kilograms. See, by standardizing your units first, the actual math becomes incredibly easy.
But what happens when you do accidentally make a conversion mistake? Look at this incredibly important note from the text. Always, and I mean always, perform a sanity check. Just verify if you've done the right thing by checking that your converted answer logically makes sense in the real world. Honestly, it's the absolute best preventative medicine you can practice. Let me show you exactly what happens when you skip this sanity check. Our text gives us example 39.2, converting 5,600 square centimeters into square meters. Now, to go from a smaller unit like centimeters to a larger unit like meters, you have to divide. Remember our area rule? We divide by 10,000. So, 5,600 divided by 10,000 equals 0.56 square meters. But, as the book warns, what if you forgot the rule and multiplied by 10,000 instead? You'd end up with an answer of 56 million square meters. This is where you apply that sanity check. Does a relatively small area of 5,600 square centimeters realistically equal the size of a medium-sized city? No way. If your answer prescribes an impossibly massive area, your diagnosis is wrong. Just stop, flip the operation, and divide.
Okay, let's quickly review the essential baseline metrics you need to commit to memory to keep that exam score perfectly healthy. First, your 1D basics. There are 1,000 grams in a kilogram. Second, the liquid to solid bridge. 1 milliliter has the exact same volume as 1 cubic centimeter. Third, the area trap. 1 square meter is actually 10,000 square centimeters. Fourth, the volume trap. 1 cubic meter is a massive 1 million cubic centimeters. And finally, combining all our knowledge, 1 cubic meter holds exactly 1,000 liters. Keep these vital signs memorized and you'll be well equipped to spot any exam traps.
Well, we've reached the end of our diagnostic session. With the symptoms clearly diagnosed and the structural rules for 1D, area, volume, and capacity firmly defined, the ball is entirely in your court. The next time you face one of those tricky multi-part exam questions asking you to fill a 3D trench with concrete or calculate the remaining liquid in a bottle, how are you going to tackle the area and capacity traps on your paper? Just remember, convert first, watch out for those exponential jumps in 2D and 3D space, and always perform your sanity check. Keep practicing, stay methodical, and I'll catch you in the next explainer. Oh, and one last reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. See you next time.